Namaskar मित्रांनो. Today we are going to learn common emitter configuration using BJT. As this common emitter configuration gives better performance, most of the applications of BJT based on common emitter configuration. What is common emitter configuration? If you see, this is our BJT. Emitter is taken common between collector and base. Emitter is kept common between collector and base. If you can see here, we are having input side and this is our output side. Input side means we are giving supply VBB between base and emitter, which is a forward bias condition with current limiting resistance RB. Okay, so this is our input side. Again I am telling, VBB supply देतो आपण आणि RB हा एक रेजिस्टर असतो करंट लिमिट करायला. तो कंट्रोल करतो आपला बेस करंट IB. Okay, so this is called as your input current. The voltage between base and emitter is taken as VBE. Okay, the voltage between base and emitter is measured as VBE. Now we will come for output side. Here output side consists of VCC, that is the voltage given between collector and emitter. Then RC is the resistance which controls your IC current, and then we are measuring the output voltage between collector and emitter. So VCE is nothing but the output voltage which is measured between collector and emitter. Okay, तर हा आहे आपला आउटपुट साइड जिथे आपण VCC सप्लाय देतो, RC रेजिस्टन्स आहे आणि आउटपुट व्होल्टेज म्हणजेच VCE. While using common emitter configuration, we can obtain two types of characteristic so that we can understand the performance of that BJT. So these characteristics are called as input characteristics and output characteristics. So what is input characteristics? These are the input characteristics. What are the steps to find the input characteristics? In input characteristics, what we are doing? The voltage VCE. The voltage VCE we are adjusting to different values, or we are setting the voltage value at different voltage levels. Okay, म्हणजे 0 व्होल्ट ठेवू शकतो, 1 व्होल्ट, 2 5 व्होल्ट, 10 व्होल्ट अँड सो ऑन. म्हणजे आपण एक व्होल्टेज लेवल सेट करतो इथे VCE, and by keeping this VCE constant, what we are doing? We are plotting the graph between IB and VBE. Means we are changing the voltage VBE, input voltage we are changing, accordingly the current IB will change. We have to take the measurement of this IB. Okay, so at step 1 we are keeping VCE at 0 volt. We are varying our VBE so that we can plot the graph between VBE and IB. We can plot the graph between VBE and IB. So for VCE is equal to 0 volt, we are getting this graph. As we increase the VCE voltage, the graphs will shift on the right side. Okay, VCE 1 volt असताना, 5 volt असताना, 10 किंवा so on असताना आपला ग्राफ जो आहे तो राईट साइडला शिफ्ट होत जातोय. The start point of this graph or this plot is knee voltage, जिथे आपल्याला ब्रेकडाऊन होतो साधारण 0.5 volts ला वगैरे this breakdown will take place. So this is the knee voltage from which the plot starts. Okay, by using the input characteristic we can find the input resistance of this configuration. How to find input resistance? We have to take slope of any one of the plot. So here I have taken slope for this 1 volt plot. Okay, when I kept VC as 1 volt and I have plotted VB versus IB, I am taking the slope here. This slope gives me 2 points on x-axis, 2 points on y-axis. That is the difference between VB, delta VB divided by delta IB. So input resistance is equal to ratio of delta VB divided by delta IB. Okay, so that will give me input resistance for that BJT common emitter configuration. Now we will come to the second point, that is output characteristics. So what is output characteristic? Now we have to come for this second part, that is output part. Here what we have to do, we have to adjust the IB. By keeping IB at one constant level, we have to take the readings for changing VC and changing IC. So जर मी 0 milliampere ला सेट केला IB, I will go on increasing the VCE, that is voltage, and then I will get different IC currents. I will plot this graph. Okay, so VCE versus IC. मग आता IB मी 20 milliampere ला सेट केला, परत मी रिडिंग घेतला, VCE चेंज करत गेलो आणि माझं IC चं मेजरमेंट घेतलो, तर आपल्याला ग्राफ असा दिसत जाईल. As we increase the IB value, we will get the plot which is going upwards. Okay, IB 0 असताना प्लॉट बघितला तर एकदम एक्स ॲक्सिसच्या जवळ आहे. IB इन्क्रीज करत गेलो, प्लॉट वर जातोय. तर इथे आपल्याला काय मिळतं, आउटपुट रेजिस्टन्स RO. हाऊ टू फाइंड दिस RO? अगेन सेम थिंग, वी हॅव टू टेक स्लोप ऑफ एनी वन प्लॉट. ओके, स्लोप घेतला, we will get 2 points on x axis, we will get 2 points on y axis. So 2 points on x axis will give me difference in VCE. So delta VCE upon delta IC will be my output resistance. Okay, so from this input and output characteristics we will get the performance of BJT, or how we can use that BJT for different applications. Okay, for this video it is enough. Thank you.